Okay guys, this is part 5 of the MATLAB step by step, San Diego State University summer 2020, and we are continuing with matrix. But before going to the elements of the matrix, as I promised in part 4, as you can see here, I want to teach you a little about the other things that I taught about matrix in part 4. So guys, dealing with the matrix is very important in the courses like control and vibration and advanced control, nonlinear control, and even the computational fluid dynamics. So suppose that you have this A as matrix of 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, minus 3. So as I taught you in MATLAB, you can write this as A is equal to, this is recording, yeah, A is equal to 0, 0, 0, 1, right? 0, 0, 0, 2, and 0, 0, 0, minus 3. Here we go. This is the matrix that you get. But we have another type of writing here, guys, because I taught you about the zeros command. Zeros command give you a matrix of zeros, that's right, in n columns and n rows and m columns. So how many zeros we have here? 1, 2, 3, that's right. So it is 1 and 3, right? You can do the same here. Zeros 1 and 3 means generate a vector of the zeros in 1 row and 3 columns, that's right. The same here, that's right. Zeros 1 and 3. Okay, if you run it, you exactly gonna get the same result. Understand? Now, as a homework, try to find another way by using the zeros command to generate this matrix. Try to find such that. One way gonna be this. I'm gonna say A is equal to zeros of 3 and 3, means generating matrix of 3 by 3. This guys. This, I mean this, okay, do you see this? This part. So, and plus, plus what, can I do that? No, because I'm not adding this column to this, so this is not possible. So, as a homework, you try to, if it's possible, to generate this matrix by zero command that I taught in the part 4. Okay? So here we go. Now another command, another things that we can do, another example, because I want to expose you to too many things. So suppose that your A is this matrix, guys. 0, 0, 0, and 0, 0, 0, 0, and 0, 0, 0, 0, and 0, and here is 1, 2, 3, 4. This is how many? 4 by 4 matrix. Conventionally writing, you're gonna have this. A is equal to 0, 0, 0, 0, 0, 0, 0, oh, 0, 0, 0, 0, 0, 0, and now the first line, as you can see here, is 1, 2, 3, 4. That's right. This is the 4 by 4 matrix. But you can have another type of writing here. You can say goodbye to all of these, and you get zeros off. Okay. You have a zeros matrix. This matrix I'm talking about. This. Okay. 3 by 4. That's right. It's gonna be 3 by 4. That's right. And now the last line gonna be this. That's right. So if I do that, you're gonna exactly have the same result. This is very important, guys, because eventually when you go to the advanced courses like as the linear system theory, ME 696 in San Diego State or other universities, grad school, you're gonna deal with the special matrices like the Jordan form matrix and the too many things matrix. Okay, so and it's very important that you know how to manipulate them. Okay. So another that, let me tell you this, because I taught you this. A can be what? Suppose that you have such a matrix. 1 0 0 0. Okay. 1 0 0 0 and yeah, so and 0 0 1 0 0 0. Right, let me make it 4 by 4, like this, and 0 0 1 0 0 0 0 1, and here you got 100 200 minus 3 minus 4. That's right. So you can write in MATLAB like this. So you can say A is equal to, classically, 1 0 0 0 0 1 0 0 0 0 1 0. That's right. And 0 0 0 and 1. And now the last line is 100 200 minus 3 minus 4. Okay, so this matrix gonna be like this. But I taught you this part of the matrix is what kind of, see if I can highlight it. This part of the matrix is identity matrix, I matrix. So you can say A is equal to, instead of that long writing, you can say this is I4, means 4 by 4 identity matrix, obviously gonna give you the same result. So it is very powerful and very important that you know how to deal with them. Okay, now so that's it. Now let's go to the section 5 here. I'm talking about matrix elements. We use A, M, and L to use mth row and lth element of a given matrix. So let us do it together here. Okay, so if you have a given matrix of 3 and 4, and I'm gonna teach you the real applications of these operations when we go in part 10 to 15 to 20. Okay, I'm gonna give you, suppose, a example of a car, and then we're gonna derive the equation of the motion, and we're gonna put this in the MATLAB coding, and you see, oh, that's why we have to know this stuff. Okay, so this is the matrix that we get. So if I say find for me A, 2 and 2, means go and find me in second row, second element. Second row is this, second element is this, so it's gonna be, answer gonna be 6. Interesting, this, right? So if I say B is equal to 1 3 6, and minus 4 6 5, and 0 0 1, if I say M, exactly, I'm talking about this. See, M is equal to find me matrix B, third row and the first column. Third row and the first column. It's gonna be this. It's gonna be 0. Or matrix C is 1 3 6. Actually, it's like as the B, except that I think the last line is different, right? Yeah, 0 5 1. Here we go. If I say K is equal to C and 3 and 2, third row, second element. Third row, second column. Sorry, it's gonna be 5. Obviously, this is very important. Okay, so you can find that now. So please pay attention. So A, N, and this calls all elements of nth row for matrix A. This is very interesting, guys. So suppose, let me go up. Suppose you have our matrix exactly here, but the only difference is here is 0. That's right. I'm talking about this. That's right. So if I do this, let's say A, N, find this and this. Means show me all rows of the first column. Or this is the first column. All rows means 1 and minus 4. Again, I'm telling you, this command means show me all rows of first column. So what you're going to see is 1 and minus 4, no doubt. Understand? I'm repeating. So by this command, tell me, show me all the rows by the first column. First column is this, all rows minus 4. That's right. Now our B that we had previously, if I'm not wrong, it is exactly like this, but it has a minor change. It's 1, 3, 2. I'm talking about this, guys. This. And here we go. And minus 2, 6, 1, right? And 0, 0, 1. You got it? This is our new B. I say, show me this 3 and this command. Okay? It gives me, it asks me that please show the third row and all the columns. That's right. Third row and all the columns of that. So you're gonna see 0, 0, 1. Third row, all the columns of that. 0, 0, 1. Understand? Or if our C, I'm talking about this, guys. So it is our C we had previously. Here we go. 1, 3, 2, minus 4, 4, and 5, and 0, 0, 1. This is our new C. So if I say show me C2 and all the columns, so in matrix C, show me second row and all its columns. So you're gonna see minus 4, 4, 5. Understand? No doubt. So this is really, so maybe you're gonna say, hey Payman, are you stupid? So obviously I can see it, but when you go to large scale systems, like as the dog robot, the rescue robot I have in my lab, is 18 degree of freedom robot. When you develop its equation, you're gonna deal with this 36 by 36 matrix. It's a huge matrix, that's right. So you need these commands to know if you want to debug your code. Say if you have done a mistake in the coding like that, you can ask this command to specifically gives you the certain element on a given matrix. Okay. Let's go in. Yeah. Okay. Now, 6. Changing an element of a matrix. Make a matrix like this. Let us do that together, step by step. Okay. A is 1, 3, minus 5 and 6. So this is a matrix. Okay. And then define n to minus 100. Say n is minus 100. Okay. We did it. So now if I say A is equal to again 1 n, that's right, and minus 5 and 6. Okay. You see changed. This is exactly the same like this, except that A is what? Is that. That's right. Or it is simple. That's right. So hold on, there's a noise here. I have to fix it. Okay, guys, some noise is there. Okay. So now another way of the changing that I didn't have the notes. So is, suppose your A is 1, 3, 4, 8, 9, 2, and 0, minus 5, and 4. That's right. So this is the matrix. Now I'm saying that I'm going to change the second element. I mean this element. This element. Okay, 9. I want to change it. I'm going to say A22 is A is equal to A2 and 2 plus I don't know, no, -9. If I do this, look at here what happens. This 9 goes to 0. So you see that this finding and manipulating the elements is very important, guys, in matrix. Okay. Or you can say A22 is, say, A32 third, this -4 plus 4 means this element, I want to say this element is equal to new element 0. I'm changing with the -4 plus 4. What you're gonna see is this. That's right. Which is 0 again. So another is that, let me show you. I'm gonna put I'm gonna say change 0 to how much? 833 plus 100, and the result gonna be 5 plus 100 gonna be gonna be now here is 100 plus 105. So you can manipulate a matrix elements by finding the elements of a matrix. That's right. So let me teach you another thing. So say I'm gonna say A all rows and all columns. Okay, so let me go to the, so A is this, right? So let's say I want to change all the elements of the matrix. So this is that we have all rows and all columns, as I taught you in a few minutes ago. So I'm gonna say, you know what, guys? I'm gonna say square all of them. So square this. Bingo. 1, 64, 0, 9, 81, 16, 16, 4, 25. Or now this new matrix, I'm gonna say all and make it plus 100. That's right. Here we go. So plus 101, 60 to the power of 2 plus 100, gonna this number, 0 plus 100. So you can manipulate the elements of a given matrix. Recording, yeah, okay. So this is one way of manipulating matrix elements. So recording, yes. So now rank of a matrix, guys. This is super critical, important topics in all vibration and control courses. Okay, so the number of linearly independent rows or columns of a matrix is the rank of a matrix. This is an important concept in courses like undergraduate and graduate control, robotics, vibrations. So see the following matrix. So let us see that following matrix. This matrix is a 3 by 3. This is a very simple example. Okay, if we make a linear combination, for example, of the matrix columns as the following, look at here. So we are taking the linear combination of this element, this column, and this column. Okay, so R1 A D G. This is what? First column, second column, and this. So this is definitions. Okay, these are definitions. The columns are called linear independent if R1, R2, and R3 are 0. So if you want to satisfy equation 5, these columns are linearly independent if R1, R2, and R3 are 0. That's right. Otherwise, we call the columns linearly dependent. Okay, so I'm gonna contribute this, elaborate this more in the matrix determinant and the inverse and two more things eventually. So see the following matrix. So let us do that. A is 1, 2, minus 4, 9, 9, 2, 4 minus 100. Again, I'm gonna back to this for the inverse of a matrix. Okay, and 3, 6, and 5. Okay, this is the matrix that we have. Okay, so now let's go to the notes. Let me go to the notes. So guys, the matrix was this: 1, 2, 1, 2 minus 4, 9, 9. I have to do this, guys. Minus 4, 9, 9. It is, yeah, 2, 4 minus 100. 2, 4 minus 100 and what? 67 and 3, 6, 5. 67 and 3, 6, 5. Okay, guys? Okay, now look at here, guys. So, guys, this is the first column. This is the second column. And this is the third column. Now, if I make exactly the same relation as I did here, 1, 2, 3, plus R2, 2, 4, 6, plus R3 minus 4.99 minus 100.67 and 5 is equal to 0. When this is 0, I'm going to tell you. If I set R3 as 0, this goes to the hell. If I say R1 is minus 2R2, that's right. See here. So if you implement this here, that's right. What you get is R2 minus 2, minus 2, minus 4, and minus 6, plus R2, 2, 4, 6. So you see that there's a relation between these guys. R1 plus 2R2 is 0. So it says that only R3 is 0. That's right. So R1 and R2 are not 0. So because it's a trivial option. That's right. So it says that the columns of this matrix are linearly dependent, guys. Here we are. Okay. So you see that the columns. Okay. So this is. So it's clear that by setting R1 is equal to minus 2 and R2 is equal to 1, that's right, and R3 is 0, look at here again, that's right, these are linearly dependent, that's right. So you say, or another option that is, as I said in the notes, if you set R1 is minus 2 and R2 is 1, you get the same result. That's right. You get the same result because you must put this here. R1 is minus 2 plus 2 is 0. So you see that R1 and R2, that's right, R1 and R2 are not 0. So the columns of this matrix are linearly what? Are linearly dependent. Okay. So the columns of the matrix A are linearly dependent. So matrix A is not full rank when your matrix rows or columns, they are not linearly independent. Your matrix is not full rank. This is very important concept, guys, about the controllability and observability of the control systems, and you're going to see eventually in the higher level courses. So if you want to make sure that your system is controllable, you can design a controller that to move your system, for example, very simple example, to move your system from point A to the point B in a finite time by applying a proper or bounded control input. So you have to check the controllability of a given system. To check the controllability of the given system, you have to examine the rank of some specific that you will hear later, the controllability matrix, the rank of that matrix. So how you do that? You have to see that if the columns or rows of that matrix, they are linearly independent or independent. So, but when your matrix is a high order, is 10 by 10, 18 by 18, 36 by 36, it's very difficult. Okay, it's time consuming. This is important definition for constant controllable observability. So you will see in these courses, okay? But good news is that we use rank A command to calculate the rank of a matrix given. So Matlab is very useful here, okay? But let's do that together. So here we go. So say your A is 1, 0 and -4 and 6, 0 matrix. So I say what is rank of A? If it gives 2, it means it's full rank, means the columns and rows of this matrix given are linearly independent, means that R1 and R2 here are 0. That's it. Okay, so and now your B is 1, 3, 2, -2, 6, 1, 0, 0, 1. That's right. This is the matrix. If I say rank of B, it's gonna be 3. It's good. It's full rank matrix. Eventually, you're gonna see this gonna be full rank system. So means that all columns and the rows of the matrix, they are linearly independent. If I say C is 1, 3, 2, -4, 4, 5, and 0, 0, 1. So, and the rank of the C gonna be 3. It's good. It's full rank system. And then D gonna be 1, 3, 2, -4, 4, 5, 0, 0, 0. Okay. I'm gonna talk about these guys in the next class tomorrow. It's very important. Okay. In the inverse of a given matrix. Oops. Okay. I don't know what happened. Okay. Now if I say rank of this matrix, what to expect to see, guys? Is it good? Yeah. A rank of this matrix. I give you 2 minutes to don't forward the video. We are learning, okay? What to expect about this matrix, guys? Is it full rank? Is it full rank matrix? Put on the formula, this formula, and let me know. 5. Can be column, can be rows, okay? I don't think so. It's not full rank. It's not full rank matrix. Means that this matrix columns or rows are linearly dependent. Because of what? Because of exactly the last row, 0, 0, 0. Because if you put R3, 0, 0, 0, R3 can be any number because it's multiplied by 0. That's right. It can be -1 because -1 multiplied by 0. 100 multiplied by 0. So R3 can be non-zero to satisfy equation 5, that's right. So that's why it's linearly dependent. So that's why these matrix columns or rows are not full rank. Okay. Now I'm gonna connect the full rank matrix to the inverse of a matrix in Matlab. Matrix determinant. Hopefully by tomorrow. Okay. Thanks.